Hi, what's going on, guys? Welcome back to my channel. I want to share with you a really cool project, in my opinion, that I created, which is a memory game. And it's been a long time since I really enjoyed coding a project. So I really enjoyed it because it's actually a game. So it's like a web application, and it's a game. And you also, when I finished it, I could also play it, and I could also play with friends and stuff like that. And by the way, I also deployed it, so I will post a link in the description so you can check it yourself. But anyway, what I wanted to say is that I found this really cool website that has really cool ideas for projects. I actually found it by accident. So here, as you can see, there are some projects that you can actually create. And what I did, I filtered these projects. I filtered by the advanced filter, and I saw this memory game project that they recommend to do here, and I really wanted to make it. So as you can see, you can go inside the project, and they have some instructions and stuff like that you can follow. Also, I think that if you get a paid membership or something, you can actually get the assets and stuff like that. But I didn't care about any of that, so I just made it myself. And I made it a little bit similar to the design, but not exactly what like they wanted. So anyway, let's go through a quick demo of the functionality that I created for this game. So let's go to our version. So as you can see, we have here at the top, we have two buttons for restart and settings. And we have at the bottom some details about the game, the current game. So let's start first with the settings. I want to show you that you can change the mode from 1 player to 2 players, and you can change the difficulty from 4x4 to 6x6. And of course, you have here option to start a new game and back to game. So back to game will bring me to the game that I was playing. So if I go to the settings, by the way, I also wrote this over here, that if I change any of these settings, the game will be it will automatically create a new game. So for example, if I choose to play 2 players and go back to game, it will be a different game. So anyway, this is the mode for 2 players. So you can see the score for player 1 and score for player 2. So let me show you a little bit. It's a very basic memory game, so you just choose the chips. And of course, as you can see, when I click on the chip, it changes color and reveals its value. So let's try to get a match. Alright, I found a match, and as you can see, when I find a match, depending on the player that I'm currently playing as, my score is added over here, and now I have another turn. So if I make a mistake, so let's say 8 and 7, the turn is going to be the other players. So as you can probably guess, it's going player 1, player 2, and so on, until you make a current match, and then you have another turn. So let's see the mode for the single player. So if I go to settings and change it to player 1, let's start a new game. Here you can see a timer and moves. So basically, at the moment that I start playing, the timer will run and will count the moves that the player is doing. So let's say 4 and 8. This is the wrong one. So you can see we have moves is up to 1. Let's make some more moves, so we'll see that actually the number is going up. Yeah, so I think that I saw a 4. Yeah, so 4 and 4 is a correct match. And of course, when we finish this game, basically, when I all the matches, the timer will stop, and then you will see your result of the time and the moves that it took you to finish the game. So another thing, the restart is actually going to restart the current game. So as you can see here, we have 4 and 4. And if I restart this game, the values will be the same. So 4 and 4 is still going to be here. But if I want to make another game, like a new game, I go to settings and then I go to start a new game. And now these two will be different numbers. And the last thing I want to show you is that we can change the board to 6 by 6. So I can also play as a single player or two players. And let's say start a new game. And now we have 6 by 6 board. And the last thing of this, the last feature kind of, is responsiveness. So if we make a small screen, so all right, so let's say that we play on a small screen. You can see that the board is a little bit smaller, and the placement of the buttons is a little bit different. So this web app is also responsive. So let's go to settings, and you will see the responsiveness for single player. And yeah, so here you can see these stats are stacked on top of each other. Yeah, so this is basically it. So this is our small memory game. So what I want to do is to go like in an overview on the code, because it's actually kind of a complex logic to manage all these states and all this stuff. So I'm not going to go like deeply inside each function, what it's actually doing. I'm just going to show you a brief overview of the project, what was my approach of making it. And of course, you will have a link to the GitHub, so you can see this project as much as you want and go into details. By the way, I think this is a really cool project that you can put on your portfolio, so you can even get it from my GitHub and you can even improve it or do it. I can even challenge you to do it in your way without looking at the code, and maybe you can send me your version of the game, and I will be glad to review it, see some other approaches. All right, so let's make an overview of the code and the project structure and a little bit about the components before I show you the app itself that contains everything inside of it. So I think that what we will begin with is the utils folder. So in our utils folder, we have two very important things. Actually, one of them is very important, that is the function that is generating the board itself and generating random numbers to the board, depending on which board I choose to play. So it's a very generic function that is doing only that thing. So let's go to generate game board first. All right, so let's look at what is going on here. So we have here the function generate game board. So generate game board is going to receive a type, which is a game type. And the type is going to be either 4 by 4 or 6 by 6. And what is going to be returned from this function is an array. Basically, it's a multi-dimensional array with numbers. So as you can see over here, if we hover over this, basically, yeah, I wanted to see that actually, I wanted to see the type that is being returned like this, so you will understand. So it's an array of arrays of numbers. So this is how we create this board, basically. And as you can see here, we have two variables that are being changed depending on which game type is being provided. So if the type is 4 by 4, the rows and columns will be 4 and 4, and else there will be 6 and 6. And here we just having a for loop, two-dimensional array, and we're going to insert to each of them 0 by default. So if I console log this board variable, so here you can see that for I equals 0, I smaller than rows, I plus plus, we're doing board.push empty array, and for each empty array, we are pushing at the position of I, so we are pushing zeros to the arrays. So this is what this thing is doing. And then we have insert random numbers to board, which is actually inserting, getting the logic for inserting random numbers to the board. So this one is kind of a little bit more complex. So here we are getting the board. So basically the board from here. And we're having here three variables. So computed board is going to be board at the beginning, number of spots, and max number. And then we calculate what is the length of the computed board. So basically it can be either 6 or 4, because we are having either 4 arrays or 6 arrays inside of it. And then we calculate these variables depending on what we get, if it's 4 or if it's 6. And this is a const that we have random spots. So basically, we here in this while loop, we are generating the random spot. So in short, what we do here, we check if object.keys random spots. So we're getting the keys from this object, random spots, and if the length of the keys is equals to number of spots. So basically, this is we need to get 16 spots for the 4x4 game board and 36 for the 6x6. If it's true, we are breaking for this from this loop. So basically, we're doing a while loop and just say while true. So this while loop will go until we have this condition fulfilled. And what we do until we don't have it fulfilled, so we are generating basically x and y. So we want to generate a random number, and we multiplied it by max number. So basically, the max number of here is going to be 4, and the max number of here is going to be 6. So to make it a little bit more clear, let's console log x and y, and I will show you what is being generated here. So let's refresh, and you can see that we are getting every time x and y with numbers between 0 and 3. So as you can see, we have 1, 3, 1, 2, 2, 0, 1, 0, and so on. So we're generating the place of where we want to place the value, basically. So all the purpose of these random spots is to actually get each position of the board randomly. So if I console log these random spots in the end, so you will see it much more clear. So let's console log these random spots. Let's get it over here. And let's look at the object of random spots. So I'm having random keys, which doesn't really matter, but what I care about is the values here. So look at this. The first value of the object for now is 3, 0. So x3 and y0. Then we have 0, 1, 2, 1, 1, 1, and each of them is a unique spot inside this board, inside this game board. So now that we have random spots, we can just loop through them and insert values. So if we go back to the code, you can see here object.values with random spots, and for each spot, I'm going to inject the current number. So at the beginning it will be 1, and it will go 1, 2, 3, 4 until we go through all of the random spots. So until we complete this for each, we're going to inject all these values, and we have over here, this is a 4x4 game board. So we have over here, how many? We have probably, we should have 16 spots. So if we have 16 spots, we inject each number. So number 1 we inject 2 times, number 2 we inject 2 times, 3, 4, and so on until we reach basically 16 spots. So I hope that makes sense. Basically after this, for each, we will have numbers from 1 to 8 in random spots each time. Right, I hope that makes a little bit more sense. I know it's a little bit confusing, but you can go through the GitHub code and you can do all the console logs that you want to understand this function. So let's go back and let's go through the other files and the other components basically. So what I want to show you next is that we have another util function, that the purpose of this function is just to get a number in seconds. So basically, when I start the interval, when I do it with set interval and I'm adding seconds each second, basically, I'm incrementing the number, and then this function is going to beautify it. And what it's going to be, it's going to be like hours, minutes, seconds format. So it's going to look something like this. So basically we have seconds and seconds prefix, minutes and minutes prefix. This prefix is just a zero or an empty string. And basically I'm calculating based on the number that I get. So to calculate the seconds, I'm doing a number in seconds, modulo 16. For the minutes, math.floor, and then I divide by 16 and do a modulus 16. And for hours, divide by 3600 and modulo by 16. So basically, this is what making this number prettified. So this function over here. And now let's go to the components itself. So inside the components, we have what I wanted to do in this project is to separate completely the logic from the components. So all these components that you see over here in the components folder are dumb components. So what I mean by that, they don't have any logic. They get everything from outside. So if we look at the buttons, for example, so you can just see some buttons with styles. So by the way, we are using styled components because first of all, it's very flexible to pass props to the styled components and define the styles based on the props. So CSS in JS, and basically I have here button props that I actually can pass to the button. So for example, here I'm passing variant. I'm doing pick on the button props, and I'm passing the variant over here. And as you can see, depending on the variant, I'm changing the styles of the button, but it's not actually very interesting. What I want to show you is that this component receiving on click from outside as props. This is a dumb component. This one is settings button. Also, it receives the on click from outside. Also, dumb component doesn't have any logic, just styling. Also for stats footer. So stats footer is this thing over here. So as you can see, it can be either this footer, or if we change it to 2 players, it can be this footer. So again, stats footer, it receives everything from outside. So we have this interface and it receives number of players, the time, the moves, the current player, first player, score, second player, score. And it's not doing anything. There is not any logic in here. So all the props are coming from outside. And if we have a number of players, which is 1, we display this UI. Otherwise, we display this UI, and we display the scores for 2 players in this case. Okay, so now we are getting to some bigger components, but still they don't hold any logic. So we have game screen and setting screen. So let's start with the game screen. So the game screen is going to receive computed board state, which is an array of arrays of chip. Chip is an interface that you will see in the use game board hook. And again, we have on chip click that is coming from outside, and also we have difficulty, which is coming from outside. And the game screen is just showing basically the board. So we have here the board wrapper, and we don't have any logic here. We have only Y. So this one is also a dumb component. Actually, nothing is going on here except the styling. And let's go to the last component, which is setting screen. And setting screen also receiving props. So on difficulty change, on number of players change, number of players, difficulty, handle back to home, handle new game, everything is coming from outside. And here we have again some styles. So basically, if we go to the settings screen, you can see here we have rows. So row component is just styling for row. And over here, we have the buttons and so on and so on. So basically, you can see what is going on here. We have some rows and so on. Yeah, so as you can see, the components are very minimalistic. They don't hold any logic, which is the goal that I wanted to use. And all the logic and everything is going to be inside the hooks. So basically we have two custom hooks that I created. So one of them is use game board and one of them is use settings. And let's start actually with use settings because I think it's a little bit less complex. So you will see a good example of how to use custom hooks. So let's go to use settings. And here what we have the use settings. So this is a convention of React to start something with use, and then it can be a hook. And here we can use state and stuff like that. So basically what we have here, we have state for number of players, and we have state for difficulty. And what I'm exposing is these two functions and basically the state. So on number of players change and on difficulty change, and I'm returning, basically exposing all these states from here, and I'm using it whenever I want. So basically, I'm using this functionality inside the app itself. So now let's go to the use game board, and this one is a little bit more complex hook. So here we have some interfaces at the top, and we have a lot of basically a lot of states. So we have state. By the way, first of all, we receive a difficulty from outside. So this hook is actually going to receive difficulty, and if it's not going to receive a difficulty, we have the default set as 4x4. So what we do here, first of all, we generate the game board based on the difficulty. And generate game board is actually the util function that I showed you in the beginning. So basically utils and generate game board. So here we are generating basically the game board. And here we have all the states for our game. So we have time, we have moves, selected chips, which is actually the chips that are already selected at the current moment. We have computed board state. Computed board state is the computed version of the board. So if we go down a little bit over here, you will see where the computed game board is generated. Let's actually search for set computed board state. So I think there should be a use effect over here. Here it is. So we have a use effect that is generating the computed game board state. And basically at the beginning, what it does, first of all, we have the dependency here of game board. And if we have a game board, we are mapping, and for each chip, so we're doing map inside a map. So for each chip, we return this object with value of chip, which is the value itself of the number that is the chip is holding, and the state of the chip is going to be by default a hidden state. So this chip is going to actually have some states. So if we go over here, so you can see chip is going to hold a value in the state of either hidden or selected or revealed. So depending on which of the state of the chip, so for example, hidden is not going to show the number. Selected is this state over here that I select the chip, and revealed is when this was an accident, and revealed is actually when I guess a current match. These two chips are now revealed. This is a revealed state. So let's go back over here. So we have the computed board state, we have board freeze. This is actually something that preventing the user from clicking non-stop on the chips. So each time he makes a selection of two chips, there is a board freeze, and he cannot click. He cannot continue clicking until the board is not freezed anymore. So after 1 second, when the chips are back to hidden, only then he can click again. So there is a start timer, current player, first player score, second player score, and is game finished. And basically, is game finished is just a check if all the cells, all the chips are in a revealed state. So here we check if every and each row dot every cell has the cell dot state equals revealed. So, and now there is the functions itself. So we have on first chip click. I'm not going to go again deeply into these functions because they basically what the purpose of on first chip click and on second chip click is just to set a new state for the chip and to check if the user made a correct guess or not. This is in overview, but of course it's a little bit more complex because we need to also add points if the user is correct or not, and to add moves if we are in a single player and stuff like that. So the more complex function is the on second chip click that we have a little bit more logic here. So here we have the logic if the selected chips at position 0. So basically if the first chip is equals to the second chip, then we have some things that we need to do here. So we need to set the new board state. We need to set selected chips back to nothing. And of course, if we are in a single player, so if we are the current player equals 1, we set first player score, else we set second player score, and so on and so on. Else means that the user didn't make a right guess, and then we make a board freeze, as I told you before, so the user won't be able to click on the board again until it unfreeze. And here we have a small timeout of basically setting the chips back to hidden. So it will be like 1 second before the chips are back to hidden. So the user will have some time to see the chips. So basically what he selected, let me show you here. So 1, and then when I click on it, after 1 second, it will go back to hidden. So again, I click on the second chip, 1 and hidden. So basically 1 second timeout. And after all of that, the set board freeze is back to false, so the user can make more guesses. And on-chip click is basically what is wrapping these both functions together. So as you can see here, that if selected chips dot length equals to 0, we are doing on first chip click. Else, if it's equals to 1, we are doing on second chip click. So this on-chip click is going to hold the logic for these both functions. And then we have some more stuff, so on restart, on new game, or just setting the state according to what I decided, and some effects. So the first effect is the game board that is actually generating the computed game board state. Mhm. And we have an effect for setting the difficulty. So each time the user is change the difficulty, we are going to generate a new game board. And we have an effect for the timer itself. So this is what starting the timer. So we have here timer interval, and if start timer, basically here we are setting the timer interval to set interval, and then we add 1 each second, and else we are clearing the interval, and if the game is finished, we are clearing the interval, and on return we are clearing the interval. So we have 3 options for clearing the interval, and this is a more complex custom hook, but I hope it was interesting to see it. And now let's go to the app itself, and in the app itself, we are just generating, like we are displaying the components, and we are using the functionalities that are being exposed from the custom hooks. So if I go over here, we are just having a state for a mode. So there can be a game mode or settings mode, and depending on this mode, we change the UI. And here we are just using these functions and state from use settings, and we are using also these things from use game board, and we have some more generic functions that are using the other functions basically. So on settings, click and handle stats reset, handle restart, handle back to game, handle new game, handle difficulty change, and handle number of players change, and all of that functionality going inside the components. So for example, this is the header, and here we have if the mode is going to be game, so we display game screen, else we display settings screen, and also here if the mode is game, we display this stats footer, and everything is going to be inside. Basically everything is coming from the custom hooks to the app and to the DOM components that I created, and this is basically the flow of the app. Alright guys, I hope you enjoyed this demonstration of a memory game that I created. Actually, I thought maybe to take it a step forward and to make it the ability to play against the computer and create kind of an AI that can play the game. I know it's a little bit advanced and I'm not very good with algorithms, but it will be a great challenge for me. So if you like this video and you enjoy it, maybe I will make a part 2 with the ability of playing against the computer. And beside it, you can take a look at this site, so Frontend Mentor, and you can let's look at this advanced section over here. So if you want, you can tell me in the comments any projects that maybe you would like to see from here. So I don't want to be like all the YouTubers that make e-commerce shop with Next.js and some clones with Next.js. I don't really care about it. I also don't really like what they did in the version 14. I think they actually messed up a little bit. But anyways, if you want to see any project from this section, write me in the comments. I will probably very enjoy it. So the first project that I actually wanted to make is this memory game, which is, I think also it wasn't too bad, it wasn't too complicated. For example, I think maybe this thing is going to be more complicated. Yeah, this is actually going to be pretty challenging, but but just tell me in the comments. And of course, if you like the video, please like. If you're new here, please subscribe. I'm very close, we're getting very close to 1K subscribers, so it will be very helpful if you subscribe and like the video. Bye guys, and see you next time.